I want to share here a little bit of the background that I have used in the next video where I talk about how you can go from a hexagon to a chair conformer. And there I talk about three rules to actually convert this hexagon to a chair conformer. And then the third rule is use the existing knowledge where I have shown the 3D diagram of hexagon and how visually how we rotate the molecule, move the molecule around to actually just see the chair conformer, right? So I want to go a little bit in depth of how you can just think about it on a plane of paper if um, with respect to every atom. Okay, so the rule is, right, if you will watch the other video, you'll get a more visual idea of what I'm actually talking about here. So go ahead and check out the other video. But here, the rule is that every wedge bond, this is a wedge, right, on the chair, it ends up on a bond facing upwards, facing up, right, or upwards. And every dash bond will end up in the chair on the bond facing downwards or facing down. And I am just making this video specifically to ensure that I tell you where the bonds facing where the bonds are facing up and down on every atom. All right. Okay, so this is the rule we want to always keep in mind when we're going from a wedge or a hexagon to a chair. Okay, so let's number these atoms, right? Um, 1, 2, 3, 4, 5, 6. Now I want to choose this atom as my number one atom. All right, so where would be the bond facing upwards? So this would be the bond facing upwards. All right, so this is the downward bond, right? And the bond facing upward would be this bond. Okay, so this is the downward, clearly the one which is pointed down. And the upward is the one which is pointed up, right? And so if we look at atom one right over here, right, on this atom, there's H1, which will end up on the bond facing up. So this is going to be the substituent H1. And then H2 is the bond facing downwards. So now this would be H2 right over here. I want to use an actual pen. So this is going to be H2, which is facing downwards, right? The same for atom 2. Now this is my atom 2. So H3 is facing upwards. So now atom 2 is slightly different, right? So on my atom 2, the H2, the bond which will face up will go vertically up. Okay. And now the bond facing downwards will be at an angle. Okay. So now the bond at the bonds at carbon 2, H3 is facing up and H4 is facing down. And now again at H3, the bond facing up is at an angle. The bond facing down is perpendicular. So at carbon 3, now, right, at this carbon, right over here, H5 is pointing up, H5 is pointing up, and H6 is pointing down. Okay, so now you will see that alternative atoms, this one and then this one, they both will have the bonds facing up at an angle. The bond facing up at an angle and the bond facing down are the ones which are perpendicular, right? And now if you see this one, and let's talk about, let's say carbon 6, the bonds facing up will be perpendicular and down are at an angle, right? Okay, so I could just really well color code it. So I'm gonna say this is purple and then this is purple because they are similar because So this one and this one and carbon 6 are similar because the bonds pointing up, right, are perpendicular. And for the green set of carbons, the bond facing down are perpendicular. So that's the kind of key information that I missed out or I did not detail out in the other video. And now on my carbon 6, I have H12 facing, right? This is carbon 6, H12 facing up, right? H12 is facing up and H11 is facing down. And then I'm just gonna do alternate ones first. So then this is also alternating to carbon 6. So at carbon 4, this is facing up, right? And then what's facing down would be this bond, right? This bond, okay? And this is up. So on my H4, this is H4. And on my H4, what's facing down, what's facing up is H8. So this is H8. And then what's facing down is H7. And this is H7. Okay, and then you can do the same for carbon 5. What's facing, this is down. And now up is at an angle. So for H5, what is up on atom 5? What is up is H10. So H10 is facing up and H9 is facing down. Are we done? Yes. So now you'll see that the chair conformer has two set of atoms. The one, right, where the lines are meeting. There's one where the lines are meeting by intersection of the lines facing down. And this is what I'm talking about, the green ones. So, or the carbon atom forming from the intersection of lines facing downwards, right? Again, intersection of lines facing downward. They're all the carbons which have green substituents. At all of these three carbon atoms, what we are seeing is this one, and this one, that when you point down, that goes perpendicular, right? Whereas on the other set of carbon atoms, right, when you go up, the upwards is perpendicular and the downwards is at an angle. Let me show you where they are. So at this one, and this one, the one which has all the purple colored substituents or hydrogens, right? They all have the bonds facing up at, or not at, the bonds facing up are perpendicular and the bonds facing down are at an angle. So these are two different sets of carbon atoms that you have to know about, and they're slight different characteristic that will help you place your substituent, right? So now once you know that these are all the different types of carbon atoms, and this is how you should place your substituents. Once you have this knowledge, you can easily pick up a substituent. So I used H's as my substituents. Now, whenever these substituents are any other substituent with carbon atoms or any other hetero atoms, nitrogen, oxygen, fluorine, chlorine, you just pick that atom up and place it where it belongs in the chair conformer. All right, so good luck and we will meet next time.